This is the MAT140 lesson number 4, quadratic cost, revenue, and profit functions. The example says Mr. Snyder makes pretzels. The cost of making X thousand pretzels per week is C equal X squared minus 32X plus 400. The revenue from selling X thousand pretzels per week is R equal negative X squared plus 78X. The units for C and R are hundreds of dollars. Part A, let's find the equation for profit. Part B, graph the profit equation, find and explain what the vertex, x-intercepts, p-intercept mean in a business context. And part C, suppose that Mr. Snyder needs to make $50,000 in profit per week. That would mean that P equals 500 because, as you see, the units of cost and revenue are in hundreds of dollars, and therefore profit is in hundreds of dollars. And so to make 50,000 in profit means that you'd have to have a profit of 500 hundred, right? 500 hundred has 4 zeros, and that's what 50,000 is. So to have 50,000 in profit means your P value, profit value from the function is 500. That is to say it's $500 and 500 again, that's 50,000. So anyway, just, I don't know, to be careful with units. It's not intended to be confusing, certainly could be confusing. Sometimes we have to handle units that are different, and so this is an example of that. Include this line on the graph above and find where the line intersects the profit curve, and use algebra to find these points and show work. Write a sentence explaining what level of production is needed to achieve the desired profit. We'll use Desmos.com. You can use a similar website, produce an accurate, professional-looking graph, print and attach the graph. Label the axes, vertex, and intercepts in your graph, and restrict the graph of the profit function to x greater than or equal to 0, because x is the number of pretzels. It's actually x is the number of pretzels in thousands. So if x was 1, that would actually be 1,000 pretzels, and x equal 2 is 2,000 pretzels. So we're not going to have a negative number for x. It's 0 or greater. So we'll restrict the graph to only represent values of x that are greater than or equal to 0, and also label the P equal 500 line in the graph. So let's start with part A, find the equation for profit. So profit is revenue minus cost. So profit as a function of x is the revenue function minus the cost function. Distribute that negative to each term, and now we can collect like terms. 78 and 32 makes 110. So that's 110x minus 400. And so this is the profit function. And that answers part A. Now go into part B, graph the profit equation, find and explain what vertex, x-intercepts, and the p-intercept mean in a business context. Now, when you do this as an assignment, you can use the calculator and the computer, specifically the computer, to produce a very accurate graph. But when it comes to an exam in class, like the midterm, when you're taking a midterm, you don't have a computer to do this, and you need to be able to do this also by hand. So let's do this finding the vertex and the intercepts by hand, and then we'll use the computer to check that we got it right. So very important part about a quadratic is the fact that it has a vertex. Vertex is the turning point in the curve. So it's important to keep in mind that a vertex is a point in the graph. It's a point in the parabola where the parabola turns. It's either a maximum or a minimum for the parabola, depending on whether the parabola opens up or opens down. We can tell right away that this starts with a negative. That means the parabola shape will be opening down. That means that when you find the vertex, it'll be a maximum. It'll actually be, in this context, the point where we have a maximum profit. So starting with a negative, or let's say a negative coefficient on the quadratic term, means that parabola will open down, and the vertex will therefore be a maximum. If it started with a positive, it would have been smiling, and the vertex would be a minimum. So how do you find this first coordinate Well, the formula is negative b over 2a. And so negative b, that'd be negative 110 over 2 times negative 2. And that's because I have a equal minus 2, b equal 110, c equal negative 400 in this particular function that I'm trying to graph. So we start by finding the vertex, and we can use negative b over 2a. That's negative 110 over 2 times negative 2. That's 110 over 4, and that would be 27.5. So we have a value of 27.5 for the first coordinate of the vertex. And to find the second coordinate, of course, you just figure out what is the profit at 27.5. So that would be just plugging in 27.5 into the function. And that's 1012.5. Now, what does this mean in sort of a business context? Well, if you made exactly 27.5 in the production level, then your profit is 1112.5, but actually we need to think carefully about the units. Is that 27.5 pretzels? Actually, it isn't. The X was measuring, how was it given? X is in thousands, so 27.5 thousand. So, and the profit was, what were the units of profit? It was in hundreds of dollars because revenue and cost were in hundreds, so profit's in hundreds. So if this is in hundreds, you could say 1112.5 dollars. But it's nice to make that a little bit more natural the way that we state it. So let's write it one more time. Since it's 1012.500, you could just multiply this number by 100 and you have the number in dollars. So multiplying it by 100 moves the decimal over 2 places. So we're looking at 111250. And so $111,250 when production and sales, because we're kind of assuming those are the same. If you multiply this by 1,000, it moves the decimal 3 places, and so that you could just say that's that many pretzels, so 27,500 pretzels. All right, that's a lot of pretzels. So not only do we know this many pretzels produces that profit, we know that that is the maximum profit you can get. It's at that production level. Okay, now it makes sense to do the vertex first in order to do the graph because it's such an important part of the graph of a parabola. And then another thing that would be good is to get the P-intercept because it's very easy to do. And if you have the vertex and the y-intercept or the P-intercept, these are easier than doing the x-intercepts, and they can give us some idea as to what to expect for the x-intercepts. It's a way of catching an error is doing the easier parts first. And so if I messed up later in a harder part of the problem, I could catch that by it not agreeing with things that I was more confident with because those things were done and they were easier. So let's do the P-intercept. The P-intercept happens when x is 0, and that's an easy one. It's the profit you make when you have 0 production and 0 sales. So, and it's when you plug in 0, you get the P-intercept, when you plug in 0 for the x. And now the profit function that I'm working with is this guy right here. So if this is the profit function, when you plug in 0, of course, you get negative 400. So that's the P-intercept. What does it mean in a business context? It's the profit when the production level is at 0. Now, it's not just negative $400. Profit was in hundreds. Since it's a profit that's negative, you can also just refer to it as a loss, and it was 400 hundred, so I'll just multiply this 400 by another 100. So that gives me 4 zeros. So we could say loss of 40,000. So if production and sales are at 0, the losses are 40,000. 40,000 per unit of time, whatever that unit of time was. It isn't really, the time isn't really figuring into our calculation. It did say that it was per week. This was the profit per week, the cost per week, the revenues per week. So this is the profit per week. So it's 40,000 loss per week if there are no production and sales. Now we've got one more thing to do for the graph, but maybe we can use the pieces that we have so far to illustrate so far what we know about the graph. So let's put that together. We found the vertex. And if I just graph it in terms of the x and p values, it's 27.5, 1012.5, and we've got a p-intercept at 0, negative 400. So having those points, I can begin to get a sense of what's an appropriate window if I want to check this on the calculator. And I can get a sense of what the x-intercepts might be as well, or whether maybe in some cases you could identify that there were no x-intercepts. So in this case, I know that I also know the curve, the function that I'm graphing. It's this function that I'm graphing, and what I'm trying to say is that because it starts with a negative on the coefficient of the quadratic term, because the coefficient of that quadratic term, it's negative, I know that it opens down. So we can put those pieces together to begin the graph, trying to keep in mind the full scale, actually, that it could be as low as a profit of negative 400 here. And then on the horizontal scale, I'm going up to 27.5, so I could count by 10 or 20. I know this is the middle of the graph, so perhaps it'll be around 60 when it comes back down. Not exactly, because we don't have a vertex right on the axis, but something up to around maybe 60 or something in that range. So yeah, counting by 10 seems reasonable. This is production in thousands, and this is profit in hundreds. And we have a vertex at 27.5, 1012.5. So somewhere around here. And what I'm trying to accomplish here is the fact that since I have this vertex and I have this intercept here, and I know that it opens down, I have some sense as to what the x-intercepts should be. And on another possibility, if for some reason this was a different situation and the parabola opened up and I had maybe a intercept up here, and I say, well, there are no x-intercepts, so I don't need to spend time trying to figure out what they were. And if you did, and there weren't any, what would happen is you'd get complex roots. You'd get a negative inside the square root, and so you wouldn't have a real number solution to the quadratic equation, and so that would be the way of identifying. But what I could tell right now that I'm going to expect an x-intercept maybe around 5, and another one maybe around 40 or 50, something like that, just by sensing what the symmetry of this thing, since that's the middle, for 5, and then around 45 maybe. So that's a good start, but I now will do the algebra of using the quadratic formula to figure out exactly what those points are, or what those points are with a very high level of accuracy. So let's do that. What would the x-intercepts be? It's when the profit is 0. These are the break-even points for the business context. And so this is a quadratic equation, and it's not clear immediately whether it would actually factor completely, whether it would factor to rational solutions. So let's just go right to the quadratic formula, because that will certainly work directly. So solutions are found by this formula. X equal negative b, so negative 110 plus or minus the square root of the b value squared minus 4 times the a value times the c value, which is negative 400. everything divided by 2 times the a value. So minus b plus or minus b squared minus 4ac all divided by 2a. Quadratic formula. So inside the square root, 8,900, everything divided by negative 4. So the square root of 8,900 doesn't come out exact. It's therefore, in this case, I can tell that it's an irrational number, 94.34. That seems like a reasonable place to round off. We could make it more accurate. And so I got two solutions here. One of them from this calculation gives me 3.915. I think I will write it out to 3 places, even though I rounded to 2 here, because I know that actually it was in thousands, so these are not necessarily really exact. They are, I think, sufficiently accurate in the context here. So the second term, 110 and 94, the other value, this one, gives me about 51.085. So in the business context, those are the break-even points. And since it was actually in thousands, both of them, X measured the production in thousands. That's actually 3,915 and 51,085. These are the break-even points. 3.9 and 51 in the graph. 3.9 maybe about here and about 51 in the graph, but then in terms of the business context, you could write the units. You could, I mean, it's not wrong to say 3.915 thousand. It wouldn't be wrong to say 51.085 thousand, but it's also correct to say 3,915 and 51,085. Okay. So we've got those 2 points now, the break-even points, and we've got the x-intercepts, the vertex, the p-intercept. All right, that's it. You do the graph. So this is the way you would approach it if it was a test question that you had to write out by hand, labeling vertex and intercepts. The vertex was at 27.5, 1,112.5. Labeling the intercepts, they were at 3.9 and 51 roughly. This is a fixed cost. It's the P-intercept. And it was negative 400 when you plug in 0, negative 400 in 100. So that was the $40,000 loss if there's no production. Okay, so I think that ends part B. So then moving on to part C, suppose Mr. Snyder needs to make 50,000 in profit per week, which is when P equals 500. Include this line on the graph above and find where the line intersects the profit curve. Use algebra to find these points and show work. Write a sentence explaining what level of production is needed to achieve the desired profit. So we want a profit to be 50,000, that is P equal 500. So let's figure out what values that requires. Now, since this is the profit function that we've been working with from the very beginning, we'll now set the profit equal to 500, or at least the P value equal to 500, representing 50,000 in profit, and find the value, the production level, the value of X that would make this true. Well, this is a quadratic equation, but to use quadratic formula, we need to bring all the terms to one side, make it equal to 0. Okay, solving with the quadratic formula. Now, in this case, it comes out the square root to exactly 70, so it actually could have factored, but didn't see that coming. So, and I know quadratic formula works every time, so that's why I just automatically went to that, but it actually would have factored. All right, so since I'm getting x equal 10 and x equal 45, x equal 10 really means 10,000 pretzels, and x equal 45 really means 45,000 pretzels. So I could say that if the productions and sales are at 10,000 or 45,000 pretzels, then the profit is 50,000 because that's where P equal 500. Okay, and that is part of part C, but the other part of it was to include in the graph that we just did this line where profit is set at 50,000. So let's do that. If I go back to my graph, right here at 500, we could draw a line right across. This is the constant line P equal 500. And it's at these two levels of uh, these 2 points where we profit uh, hits 50,000. We just found these 2 points, 10,000 and 45,000. So right at 10,000, and then this point, it's more like 45. So can actually, now that I have that extra point, I really can make the graph better. So good thing I have a pencil. So that's the line P equal 500, and right at 45, that's the level of production. I think part of the problem was I created a little bit too much space right there. Of course, um, doing this by hand, it'll never be as precise a graph as you can get on the calculator or the computer. But by doing it by hand, you have a good intuitive feeling of what's going on, and you can really explain and understand what's going on. And it's one of the things that I'll be looking for on the exam is that you can graph this by hand. And then, so try doing this by hand in preparing the assignment. But then also part of this assignment is to put it on the computer. And of course, you can check it with the computer, and you can produce a very accurate, nice looking, clean graph that confirms with what you did by hand. And getting 50,000 in profit really means 500 in the graph. And here, this is 45,000 pretzels, 500 in the graph, and actually 50,000 in profit. All right, let's check this on the computer in Desmos and produce a nice graph that you could print and submit. So doing this in the exam, you got to do it by hand. On the midterm, by hand, using a graphing calculator if you would like. Definitely don't need the graphing calculator. Of course, you can check it with the graphing calculator, but you got to go through the process of finding the vertex and showing the work for finding these intersection points with this constant line P equal 500 and going through the algebra of finding the x-intercepts. One or maybe both of those, it's going to specifically ask to show that work. It's basically just applying the quadratic formula. But then as far as submitting electronic assignments, we could do this on Desmos and produce a graph for the when you're doing an assignment at home and you submit it on the computer, you can do it. You can use the computer as also an important skill to know how to do that. So let's go graph this on Desmos. Profit is negative 2x to the power 2 plus 110x minus 400. And, well, we can include the restriction that x is greater than or equal to 0. But you could have negative profit, so I don't need to restrict that. And well, this is just not a real good scale for this situation. So let's adjust the scale. Let's say, since that point we already know that it's an x-intercept, it was around 50 something. Let's go from maybe -10, just because something like that would allow me to see the vertical scale. So -10 to maybe 100. Let's start with that, see how that looks. Okay, that looks pretty good. We could maybe make it like 80. And then that horizontal scale is, well, it was number of pretzels in thousands. Just by adjusting the horizontal scale, it's already adjusted the vertical scale for me. Could leave it at that, or so maybe I'll just go from -1000 up to maybe 1500, or I could just left it the way it was. That's pretty good. Another thing to include in the graph is the constant profits. So let's just say y equals 500. That creates that. Yeah, I could adjust it, but I want it at 500. And then I could look at these points. This point was the vertex. We could label that point 27.5, 112.5. That's the max profit. We could go back to these points, and they were the same ones that I got from the quadratic formula. These are the break-even points. This was at like 3.915, and this other one was like 51.085. The vertical scale, forgot to label that, that was actually in hundreds of dollars. So we could include these or not. It didn't specifically say. Yeah, it did say write a sentence explaining what level of production is needed to achieve the desired profit. Oh yeah, I did that. So I think with that work included, I think the graph is complete. Okay, so that should do it. Hope that was a helpful video.